Every discipline has branched out from something, and computers own a lot to mathematics. Electrical engineering, physics, and even philosophy have influenced computer science, but it is mathematical principles that allow computers to do anything meaningful. At the same time, computers can help with math education. Programming can be a pathway to being able to play with math, interact with it, and feel it for students who wouldn't otherwise find the joy in it. In this episode, we'll look at some of the shared ideas of math and computer science through 3 areas: arithmetics, geometry, and logic puzzles, and how to introduce computer science through math to your students. Math is more than calculation, and while a computer is excellent at calculating, it isn't very good at conceptualizing problems and applying them. There are big questions often hidden in routine events and concepts. How do we count? Why do we count? What is a number? How different is 10 from 100? And 1,000 from 100,000? Interesting estimation questions can also start from real-world problems. How would you estimate the amount of students in your school? How many doorknobs are there in your building? Geometry and computational thinking share natural borders. Everything from how computers calculate video game character shading to how programmers design websites relies on simple geometry of triangles and squares. Furthermore, exploring geometry can help students reinforce concepts of pattern recognition, decomposition, sequencing, and algorithmic thinking. Puzzles are about the underlying fabric of math. Logic is an essential tool for both math and programming. Riddles and puzzles allow the kids to exercise their reading abilities and their skills for abstraction. Riddles also help students and teachers to understand what kind of thinker they are and to enjoy the process of finding the solution to a problem. This entails enjoying not knowing the solution and learning to give tools or clues to clarify how to proceed from one point to the next. Famous computer science puzzles like Bridges of Königsberg and Towers of Hanoi offer tangible and real pathways into some of the big, abstract algorithms that power our world. In the same way, mathematics sometimes seems nebulous and abstract, computer science can be intimidating. Like mathematics, programs don't exist in a physical sense. They're conceptual things, ideas that exist only in the programmer's mind. There is nothing new in integrating math and computational thinking. Already in the 1980s, Seymour Papert said that programming is to learning mathematics, but living in France is to learning French. So there is a natural connection between computational thinking and mathematics, offering creative and new ways to engage all kinds of learners. And as a teacher, your role is to spark the sense of joy and help connect the deep, abstract notions of math with real life.